Hello, Namaskar. In this PPT podcast, let us talk about Oppenheimer, the physicist who is in limelight due to a biographical movie on him recently. I recall first a shloka from Srimad Bhagavad Gita that says, Kalosmi lokakshayakrit pravruddho. You would be surprised, or perhaps you would not be surprised. It is now well known that physicist Oppenheimer was an ardent devotee of Bhagavad Gita. Actually, he recalled this and another shloka as he saw the frightening explosion of the nuclear bomb in a test conducted in a secret project during the times of World War II in 1945. Today, J. Robert Oppenheimer, 1904-1967, is back on the world stage due to a movie of the same name released recently. You might have seen it. But for us, he was a theoretical physicist first. Therefore, we begin by highlighting his young age contribution in 1927 in the early days of quantum mechanics. Oh, quantum mechanics, you would react perhaps. Yes, please be ready for a quantum sip as we talk about the Born-Oppenheimer approximation. Don't worry, this is not a prerequisite to see the movie, of course. 1926, the quantum mechanics era was heralded when Erwin Schrödinger established what we now call the Schrödinger equation. This is written in symbols as H psi equal to E psi, and it is in a time independent three-dimensional fashion. Soon, people started working on this, and exact solutions of the equation were obtained for a few simple cases. For example, for hydrogen atom, the energy levels were derived and the spectra were explained. Fine. A challenge now was to extend it to molecular problems, H2 molecule being the simplest one. Here, we have to consider the motion of electrons as well of the nuclei, that is, the rotations and vibrations. Accordingly, the position variables needed are R1 and R2 vectors for electrons, with R vector as the internuclear separation. All this and the terms in kinetic energy and potential energy become problems, and the Schrödinger equation is difficult to be solved exactly. How to crack the problem? Born and Oppenheimer noted that luckily the mass ratio proton mass mp to the electron mass me is much greater than 1. Also, the electrons are fast, quick, agile, while the nuclei are slow and sluggish. Thus, the Born-Oppenheimer approximation consists of the following procedure. It is to separate the full Schrödinger equation into nuclear and electronic equations approximately, and all this resulted into a further progress. Let us now come out of quantum mechanics and proceed. Oppenheimer then went to USA and turned to other problems of theoretical physics, as he was not interested in any experimental work. He got interested in Bhagavad Gita and also learned Sanskrit language. Meanwhile, rapid developments were taking place in the world in experimental and theoretical physics. 1932, neutron was discovered. Nuclear structure became clear. It also became clear that energy scales on the nuclear level, on the scale of the nucleus, are much higher. The atomic nucleus could be a big source of energy, many people thought. To gain energy from the nucleus, we have to smash atoms at will, said Einstein. Okay, but how to do that? And so the particle accelerators were developed for charged particles. It was recognized that neutrons, being neutral, would penetrate into the nucleus easily. In 1938 came the turning point. Otto Hahn, Frisch Strassmann, Lise Meitner, and Otto Frisch discovered the nuclear fission, breakup of the uranium nucleus with slow neutrons. The process emitted two or three neutrons and a large amount of energy. The nucleus was splitted and the news from Germany spread to USA. And a friend of our hero, Oppenheimer, read it while sitting for a haircut. So excited he was that he ran half haircut to Oppenheimer and broke the news. Robert, hesitant initially, thought about it, but then he agreed that yes, fission indeed released energy. The name fission was given from the fission of a biological cell. A race started for achieving sustained nuclear fission in the US and in the German labs in a multidisciplinary way. Here is the picture of the nuclear fission process. This is now known even to our students of Standard 12th. 1939. The World War II started, and Einstein wrote to the US President that in Germany the Nazis were working on a new powerful weapon, the atomic or the nuclear bomb. The US joined World War II in 1941, and soon after in 1942 it started the Manhattan Project for developing atomic bomb. Meanwhile, 1942, Enrico Fermi built the Chicago Pile, a big device for getting the sustained nuclear chain reaction. Oppenheimer was brought into service in the Manhattan Project. The American Army generals were perhaps surprised and impressed as well. A theoretical physicist here in the crucial work of war? Yes, but he was assigned the task in view of his quick grasp of the problems. The focus shifted to Los Alamos, New Mexico State, and Oppenheimer was appointed the director of the Los Alamos lab for the Manhattan Project. The secret project gathered momentum in spite of problems like getting the fuel, say uranium, in sufficient amount, etc. 1945, the first ever nuclear bomb test was planned using plutonium, and the test was known Trinity Test. Trinity Test. Where was it conducted? Who were present there? The Trinity Test was conducted on July 16, 1945, in the deserts of New Mexico State, and those present with Oppenheimer were Enrico Fermi, Hans Bethe, Richard Feynman, and several others. All were watching anxiously from a safe distance, and Fermi was to estimate the TNT, the power, the explosive power of energy of the bomb in his typical art of estimations. As the test bomb exploded, Oppenheimer saw the mushrooming cloud of dust and sand with thunderstorms and bright flashes of light. He was reminded of the shloka from the 11th Adhyaya of Bhagavad Gita, Devi Surya Sahasrasya, like 1,000 suns shining together. Later, he recalled Kalosmi, and that is the sloka we quoted in the beginning. The sloka Kalosmi means, now I become death, the destroyer of the world. Actually, Kala means time. Time began to flow like a torrent. August 6, 1945, the first ever atom bomb was dropped by USA on Hiroshima city of Japan and on Nagasaki 3 days later. Thousands of innocents were killed. Many more were injured. There was a huge loss of property. The humanity was stunned. Though the World War ended, the world was in tears, sobbing. Our hero, Oppenheimer, the father of the atomic bomb, was deeply distressed as he came to Princeton. Friends, August 6th to come now is observed as the Hiroshima Day in the world today. Oppenheimer, the movie, is a biographical drama of events before and after the Trinity test and the bomb dropped on Hiroshima. The movie tells us how discoveries in physics could have tremendous impacts on the mankind. Sometimes good, sometimes kind of evil. Post World War II, an era of Cold War started. Russia, the Soviet Union or the USSR joined the nuclear arms race. Preparations began for more powerful, dangerous bombs. The fusion bomb or the hydrogen bomb was also tested. Oppenheimer was against it. The physicist was in turmoil mentally and also politically. But on to timeline again. August 15, 1947, India won freedom. We were quite fortunate to have Raman, Saha, Bose, and the then young Homi Bhabha and Vikram Sarabhai and others at that time. The Atomic Energy Commission was established in India in 1948, and we slowly began to develop nuclear reactors for peaceful scientific purposes. Here is a historic photograph. Homi Bhabha is remembered as the father of the Indian nuclear programs. Friends, there was another offshoot of the Cold War era after 1950, and that was a race to gain supremacy in space, outer space, the space race. India's space programs began very modestly in the form of rocket launching experiments in 1963. Dr. Vikram Sarabhai is remembered as the father of our space science programs. ISRO, as we know, is a great success story, and we anxiously wait for Chandrayaan 3 to deliver us the good news by August end. And so, dear friends, we have come a long way from Oppenheimer's quantum mechanical theory, the approximation, to the nuclear fission and the fission bomb test, and to the havoc on Hiroshima and Nagasaki on August 6. The movie Oppenheimer prompts us to recall many such developments post World War II, and also we recall India's nuclear and space programs. Now, in the end, just for fun, imagine a scenario. You go to a theater to see this movie, and the person on the ticket window poses a question to you. What is Born Oppenheimer approximation? Don't worry, it is not going to happen. Enjoy physics. Anyway, please send your feedback at this mail ID. Thank you so much.